We now do an example on using calculus to calculate the position, velocity, and acceleration. So let's assume a particle is moving in one dimension, that's the x direction, and we start from x equal to 0 or somewhere else. And the particle can move forward or backwards, and its position as a function of time is given by 3t squared plus 2t plus 4. So it's just take an equation that gives us its position as a function of time. And the question is, what is its position, velocity, and acceleration at t equals 5 seconds? So what are these? That is our question. So we know that the velocity is dx over dt, and the acceleration is d2x over dt2 or dv over dt. So first let's find the position at x equals 5 seconds. So it's simply a substitution. Put t equals 5, so 5 squared plus 2 times 5 plus 4, and when we solve that we would get 89 meters. Now let's look for the velocity. So the velocity at any time is dx over dt, which means we want to differentiate this equation 3t squared plus 2t plus 4, and that would become d over dt. That would become 6t plus 2. And then v at t equals 5 seconds would become, this becomes 32 meters per second. And now the acceleration is the derivative of velocity. So we would take 6t plus 2 and differentiate that, becomes 6. Okay, so that is the answer. It's constant. So we differentiate the position to get the velocity, and we differentiate the velocity to get the acceleration. Now we do another example, and this time we know the acceleration as a function of t given by, let's say, 4t plus 3. The units would be meters per second squared. So the acceleration in this case is a function of time, so it's not a constant acceleration. And we should also be given for this that the velocity, the initial conditions should be given. V at t equals, let's say, 2 meters per second at t equal to 0, and the position at t equal to 0 is, let's say, 5 meters. And the question is, what are the acceleration, velocity, and position at, let's say, t equals 3 seconds. So we know that the velocity is the integral of a dt, and the position is the integral of v dt. So we can first solve for a at 3 seconds just by plugging in the value of t. It becomes 4 times 3 plus 3. That becomes 15 meters per second squared. So that's the first answer. Now we want to find v as a function of t, which is the integral of a dt. So the a is 4t plus 3 dt, and that becomes 4 t squared over 2 plus 3t over 1 plus the constant of integration, which we get from the initial condition. So v at 0 is 2 meters per second, and that will be 2 plus 3 times 0 plus c, and therefore c equals 2. So now we can substitute this 2 over here to get the equation for v as a function of t as 2t squared plus 3t plus 2. And now we can solve this at t equals 3 seconds. So v at 3 is 3 squared plus 3 times 3 plus 2 becomes 29 meters per second. So now we want to get the position, so the position will be xt will be the integral of v dt, so that's going to be the integral of this equation, 2t squared plus 3t plus 2 dt, 2t cubed over 3 plus 3t squared over 2 plus 2t plus the constant of integration. So x at t equal to 0 becomes 0 plus 0 plus 0 plus the value that we took was 5. Therefore c is 5. And so our equation becomes xt is 2 by 3 t cubed plus 3 by 2 t squared plus 2t plus 5. And then x at t equals 3, just substitute 3 here, 3 cubed plus 3 by 2 t squared plus 2t plus 5, and that would come out to 42.5.